In this case, we're going to be demonstrating sort of the effect of convolution and the whole concept. Now what we have on the top line is kind of a constructed signal. The blue line is actually three different sine waves at varying frequencies. The first one comes up to here, and it is of a height 1 but a certain frequency, about 25 samples per period. And so then the second one is actually similar, but now it has 2 periods in that time frame. And the final one has 1, 2, 3, 4 periods in that. So they have the frequency of 1, twice that, and 4 times that frequency. Now what we're going to do is convolve it with a pretty simple impulse response or filter shape, right? One of the things we'll be developing with our FIR filters is we are building this shape here to create a certain frequency response. So we made a simple one. It's just a little triangle, and it's shown overlaid here. Now what we're going to do is cross multiply and add those up, and that creates the output down below. So it's paused, waiting for us to start, and what we see as the thing moves along, each point is generated, we get something out, and we see that it actually has a bit of gain to it. What was 1 height on the input now comes out to close to 3. This is at the low frequency point. Note it's going to speed up here because it would get tiresome if it didn't. And we see that the higher frequency component has a smaller peak. It's down from the other one. And now it hits this really high frequency, and it really is pronounced that it's coming through smaller. The whole point of the FIR design will be to come up with this shape, get this filter shape to give us the response to different frequencies that we want to see. Okay. That's how first thing we will be talking about, though, is just the generic effect of shape and how we will have to restrict ourselves to use these.